all the computers which are not having the IP address mentioned in the request will drop the packet. Only the computer B, which is having the IP address sent from computer A as destination address, will reply to the router telling that I am the computer which computer A is requesting, and this is my MAC address. Likewise, computer B will be replying with its MAC address to the request packet sent by computer A to the router, and this MAC address would be communicated to computer A. Yeah, this is the MAC address for the IP address that you have requested, and you can start communicating. So computer A will start embedding the MAC address provided by computer B in its packets, and then it will start sending the packets to computer B. This is the normal ARP operation. So, but actually in between, when I told the router will be sending packets to all the other computers in the network, they will actually drop because they don't have the they don't have the actual IP address that is found in the destination. So they will drop the packets. But in Wireshark, what we are actually doing is that we are just receiving the packet as such. We're just receiving the packet as such. So this is what is actually called as promiscuous mode. Okay, so promiscuous mode means okay. So promiscuous, normally the IPs will send or receive communication only with the packets intended to it. Promiscuous mode will enable all the packets to be received even though it did not belong to the IP. Okay. So in the previous case, any packet that is coming to me, I will receive. If my interface, network interface card is changed to promiscuous mode. Okay, so normally it will not be in promiscuous mode. When we use Wireshark, it will enable the network interface card to be in promiscuous mode so that I can get any packet that is passing through my computer in the network. That is what is actually promiscuous mode. This is the underlying principle of the Wireshark's operation. Okay, so start and stop the packet capture. We'll see. So Wireshark is a wonderful tool. Okay, so which is used for packet capturing. Okay, network packet capturing. So we'll see how the Wireshark is actually starting and stopping the packet capturing. So we need to always start the Wireshark as administrator. Then only the packet capturing will actually start both in Linux and Windows. In Linux, you have to start the Wireshark as a sudo user and this command prompt. Okay, so you can see here, this is the command prompt which I will be using to run the C# version of the Wireshark. Okay, so first we'll run the GUI version. We'll see how the starting and stopping of packet capturing is done. Then we will use the command line. Okay, so yeah, I have started my Wireshark. So you can see in the Wireshark homepage itself. Okay, in the Wireshark homepage itself, there are some lines which are continuously pausing. So local area connection 12, there is no communication. 9, no communication. 8, no communication. Bluetooth network 2, there is no communication. And Wi-Fi alone, there are some spikes. So that means my computer is connected to the internet by using this Wi-Fi. This itself is from the homepage itself, you could see. And then loopback traffic capture. Okay, so the loopback interface, the self interface that is having some traffic. Okay, so you can see the other interfaces. I have so many interfaces. Okay, LAN 8, 9, 12, and Bluetooth, local area connection 1 and 2. Or in all these interfaces, there is no packet capture. You can also look at the interfaces by using this command. You can see there are so many interfaces, that is LAN adapter 1 and then 2. For these interfaces at all, we have the MAC address, but there is no IP address. Okay, that means they are actually not connected. Only this Wi-Fi adapter it is having both the MAC address as well as the IP address and subnet mask and all those things. It is all the required details. It is actually there. That means it is actually connected to the internet. But for other interfaces, I'm having only IP and there is no sorry, MAC address I'm having and there is no IP address. Okay, fine. So yeah. Now, okay, so this is the way that we need to start the capture. I just go to the capture options, and in capture options, you can see Wi-Fi is having some traffic. I'm just clicking on this Wi-Fi and then performing start. So yeah, now this is our packet capture window in Wireshark. You can see all the packets that are passing through the network interface card of my computer. It has started capturing in Wireshark. Okay, so before I say it has started capturing, it has captured till this point 4,500, 600, 700, 8,000, 5,000 packets. Before I say it gets 500 packets. Actually, I did not generate any traffic. Even then, it is capturing all the packets. So you can see per second, my computer is doing 500 transactions per 500 transactions outside. Okay, so I just stop the packet capture here. Okay, so you can use this shark symbol in the left top to start the capture, and there is a square button to stop the capturing of the packets. Okay, so yeah, we have so many options in Wireshark. In GUI, we have started and stopped the packet capture, and in command line also, we can do the same procedure. Okay, so first I just look at the interfaces. So these are the available interfaces from my computer. Okay, and yeah. Okay, so T-Shark -I WI-Fi, Wi-Fi. Okay, so because this is the name of my interface, you can see here, name of my interface. Okay, so you can use this name of this interface with a capture filter -I in the command line to do the same packet capturing which I have done in GUI. Okay, so now the action that is done in the GUI was done in CUI also. Command line interface also it is done. Okay, I just stop it by pressing Control C. Okay, so now you could see till this point 8,991 packets are actually captured. In both the cases, till this point, I have only captured the packets, but I did not save the packets. Okay, so we'll just look at some internals of the packets and then see if there is a feasibility that we can do the processing or look at some more additional information about the packets. Okay, so let me click on any one packet that is doing the.
Madam, I would like to ask one more questions, if you don't mind.
Yes, sir, please.
If you are going to filter some specific protocol like internet control message protocols, so what sort of commands we can use? So you are listing out 100 to 200 informations you are listing out. In that, I want to filter it only relevant to internet control message protocols.
Sure, sir. So filters are actually coming next. I will cover your question in that, sir.
Okay.
So filters, a specific IP, specific protocol, okay, specific source IP or specific destination IP or both. all those things we'll cover it while we are looking at filters.
Okay, okay, okay.
Okay. Yeah. Thank you, sir. So fine. We are actually, we have the packet capture. So you can see there are so many types of packets that are actually seen here. So I hope you all might be remembering the OSI 7 layers. You can see here, I'm just clicking on this ARP protocol. Everyone knows that ARP protocol will communicate till layer 2. You can see here in the second pan. Okay, there are 3 pans that are available. The top pan is for the display of captured packets, and the second pan, which I am showing here, the second pan is for showing the details about the packet, and the third pan is for actually for showing the content of the packet in hex. Okay, so this will be very much useful while we are performing some of the detection tasks by using Wireshark, or if you want to look at the complete packet capture fields. Okay, so the hex content of your packets would be displayed along with the address in which the contents are actually stored. What is visible on the side is the address, and what is visible in here is the hex content, and this is the actual content of the packets that is actually stored. Okay, so you can see this ARP protocol, it'll communicate till layer 2 only. In the second pan, you can see frame details are there, Ethernet details are there, and ARP details are there. Okay, I will show one another protocol. UDP will communicate till layer 4. Okay, till layer 4. You can see here, frame details are there, physical and data link, physical layer, and then Ethernet details are there. This is data link, and then internet protocol details are there, layer 3. And UDP, we have layer 4. Okay, so till layer 4, you will be able to see. So while we are teaching OSI layer, no, we have to teach it along with Wireshark. Then only student will be completely understanding how the OSI layer is actually working. So normally we'll just go on teaching with huge presentations and theory. Rather than that, if we teach it here, no, then student will remember it very well, and he will also just look at something ma'am is showing, something sir is showing, what is that? Okay, fine. So UDP, it is communicating till layer 3, and yeah, DHCP, you can see it is it is communicating till layer 4, and then you can see TLS. Okay, so TLS till layer 5. TCP/IP, 5th layer, you can see only in TLS. Okay, yeah, and some other protocols very lower. Local link list, this is also having till layer 4. Yeah, we have an ICMP packet. You can see ICMP layer 3 protocol. Okay, that is network layer protocol. Network layer protocol means till layer 3, you will be able to look at the complete information. Okay, fine. Yeah, so let us take one TLS protocol, TLS packet. Okay, so let me take up this particular packet, TLS version 1.2. Okay, so you can look at, we are going to look at the internals of this particular packet. So only one packet that I have taken now, okay, packet number 8247. Okay, packet number 8247. The details of this packet alone we are actually going to see. See, to look at one packet details alone, I need to have at least 2 sessions in this workshop. That much details are actually present. Okay, so when you're free, please go through each and every detail of the packet. So TLS version 1.2, we should be first remembering the protocol header fields of this TLS. Okay, so what are all the protocol header fields that we must remember? And for each and every layer, okay, so you can look at it. First is physical layer. Okay, it is whenever I am clicking, the corresponding data will also be displayed in the third pan. Okay, so the third pan, we will not be looking in more detail here, because no, we have to just work out more to understand this third pan. Rather than that, the first two pans will start looking at. Okay, you can look at it here. So frame A247, 99 bytes on wire, and this is the number of bits, and 99 bytes are actually captured on the interface with ID of this. And this is the name of name and address of the interface. Okay, so this first line itself would be an indication of whether this is a normal packets or abnormal packets. Okay, so there are 99 bytes on the wire. Whether all the bytes are actually captured here in this packet, it is yes. But if it is for some of the abnormal packets, it will be different. It will be more or it will be lesser. Okay, that itself will be an indication whether this is a normal packet or abnormal packet. And there is an interface ID that is actually given. The interface name is actually given. You can see interface description, it is Wi-Fi. Wi-Fi is the interface through which we are actually doing the capture, and this is the details of the Wi-Fi. Okay, so the computer is recognizing the Wi-Fi by using this ID number. Okay, so encapsulation type, and this is the arrival time. And normally, no, you can see this time, you may not be able to quickly get what this time is actually. So this is normally in all the Wireshark packets, the calculation of time would be done based on Unix epoch time 1970 July 1. Okay, 1970 July 1 would be the actual time where we will calculate the time difference of the present time with the epoch time, and then we will display. Because in world, you know, see, I may be having so many, I may be having packets from so many countries, and the time zones are different in every country. So the common time zone that is actually followed would be the Unix epoch time. Okay, for every packet, the time difference would be calculated with respect to the Unix epoch time. Okay, that is what is actually displayed here. And time delta between the previous captured frame, previous displayed frame, first frame, okay, and the frame number and the frame length, capture length, and frame is marked false. Okay, so there is something called frame marking or packet marking. Okay, see, when a firewall or any network capturing device is having suspicion on this particular packet, then the packet would be marked. Marked means some of the attributes of the packets need to be examined at a later point in time. Okay, that is the meaning of packet marking or frame marking. Okay, so now you can see frame is marked. Frame is marked. No, it is not marked. So that means this is a normal frame. Frame is ignored. No, it is not ignored, and it is passed. Okay, so this frame is marked and ignored will also tell whether that is a normal packet or a different or abnormal packet. And these are the protocols in the frame, and this also will give us an indication of the 5 layers of OSI. Each 0, layer 1 or physical and data link layer, physical layer, and then ether type is the data link layer, and the IP is the network layer, and TCP is the transport layer, and TLS is the application layer. So all the 5 layers of TCP/IP, the latest version of OSI, we can able to look at it in this particular packet. And coloring rule is for TCP, and yeah, this is a string that we will be using for coloring. So till this point, I have seen only the physical layer properties. Okay, physical layer properties. In the same way, you could see Ethernet. Okay, in Ethernet, this is data link layer. Again, data link layer is responsible for getting the MAC address, right? So you can see the destination MAC address. Okay, destination MAC address, and the name of the destination MAC address device. All those things you can able to look at it, and then source name along with MAC address, and the type of the address that is going to be used. Okay, And yeah, so all these MAC address related details, you will be able to look at it in the Ethernet and the Ethernet related entries. And then the third layer, it is Internet Protocol version 4. Source IP and destination IP you can able to see, and version you can able to see. And the header length you are able to see. Yeah. And yeah, the differentiated services, all those things you will be able to see. The length of the total packets, identification, flags, you are able to see. Yeah, time to live value. Okay, so this time to live value for this particular packet can be seen, and the protocol is TCP checksum calculation. We can manually do the checksum calculation with the protocol header fields. It will be perfectly verified. Okay. And the source and the destination IP addresses you will be able to perfectly see in this particular layer. Okay, layer 3. Okay, and layer 4, transmission control protocol. It is related to service point addressing. Okay, service point addressing. So that means port addressing, you will be able to see what is the source port and destination port that the protocol is actually using for doing the communication, along with the sequence number of the packet, so that we can perform the segmentation and reassembly kind of operations, right? And the flag fields, okay, this is very important. Flag fields, if they are properly set or unset, no, you can launch a very great attack. The DDoS attack, TCP SYN flood attack, all those attacks are actually launched by setting or resetting the flag fields. The SYN flag, FIN flag, and acknowledgement flag, urgent pointer. These flags would be set or reset to launch some greater attacks in the real time. Okay, so each and every letter in packet header field is very important. Okay, so make a note of that, participants. Each and every letter in the packet header attributes are very important. We have to go through for understanding the complete transmission that is happening in the network. And Wireshark provides a wonderful and beautiful interface for us to understand. Okay, sequence acknowledgement analysis you can see, and timestamps again you can completely see. So layer 4 we have seen, and this is the last layer, transport layer. Transport layer security, you can see the application data, you can see the version, the length, and encrypted application data. You can see here, encrypted application data, you can completely see here. Okay, so even if you are using the unencrypted, if you are using unencrypted communication, no, you can look at the complete packet content here. Okay, so if you are logging into some HTTP website, okay, HTTP without using HTTPS, if you are using it in a HTTP website, no, then you can look at your password here, provided if we are properly capturing that packet. So if possible, tomorrow we'll see. Okay, because this is an encrypted application data, you are not able to see. If it is an unencrypted traffic, in the third pan, in the bottom pan, you will be able to completely look at the password of the unencrypted traffic. That also Wireshark is actually providing. Okay. Yeah, so this is the complete internals of a particular packet. Okay, complete internals of the particular packet. Yeah. Now, yes, so we have seen how to capture with various options. So let me show that. So in the capture options, you can see here, enable promiscuous mode on all interfaces. In the bottom, you will be able to see that enable promiscuous mode on all interfaces. That's the major thing that we need to look at it in the capture options. Yeah, select an interface and we can start the capture and we can stop the capture, right? And we can also ping one local host and locate the same traffic, and then look at the IP address in this particular Wireshark. For example, I am actually using a tool, one more tool called Nmap. So I'm just using this command, nmap -v scan me dot nmap.org. So I want to tell you one more thing to all the participants. Whenever you are doing some scanning, kindly do not do in random network. Nmap, google.com, it is not accepted. Okay, Nmap, your college server, not accepted. When you scan an external network without any permission, then you are under legal implications. Please make a note, students. So here, no, this nmap scanme.nmap.org is a website that has been specifically provided for us so that we can scan and we can get to know how the tools are actually working. So when I'm scanning by using this nmap from this, I'm scanning this scanme.nmap.org from my computer using this nmap. So what will happen from my computer to that website? Some packets will be sent and they will be received to this particular tool. So what I'm doing is I'm just capturing those packets in the Wireshark. So I started the packet capture. Now I am just doing the scanning here. I'm clicking on scan here. So the scanning is actually going on. Okay. So it is displaying some details about the scanme.nmap.org. And Wireshark, I'm just looking at it here. Okay. So once when the capture is over, okay, so now actually the capture is over. Nmap is done, one IP address, and I'm stopping the capture. I'm stopping the capture. Okay. So you can see here, there are, again, within a glimpse of time, we have got 8,800 packets. Okay. So in this ZenMap tool, I'm just looking at starting Nmap. So scanning scanme.nmap.org means 45.33.32.156 is the IP address of the domain which I scanned. Okay, 45.33.32.156. I go to the Wireshark and actually I just sort. Just click on here. Okay, click on here. It will get sorted. Okay, it will get sorted. Okay, click on the destination here. It will be sorted destination wise. Okay, it will be sorted destination wise. So you can see here within my computer and 45.33.32.156, there are so many packets that are actually scanned. There are so many packets that are actually scanned. I actually created a traffic and then I am looking at the traffic in Wireshark. That is what I'm actually doing. I have created a traffic and I'm looking at the traffic in Wireshark. You can see here, so many packets have been sent from my computer to that domain, and from that domain has responded with so many other information by using the protocol TCP, mostly by using the protocol TCP. Okay, so because this scanning is normally not permitted, we are getting this red signal. Okay, so yeah, you can see so many packets. So if you want to see how many packets that actually I have sent to understand the communication between the source IP and the destination IP means, then I have to go and look at it in the statistics in the Wireshark. So I'm just clicking on statistics. Okay, statistics. Yeah, I'm just clicking on endpoints. Okay, so this is the IP that I have scanned. 45.33.32.156. Okay, this particular IP had 2058 packets that are originated from my computer to the remote computer. Okay, it has given 2058 communications within my computer and that computer. I can able to clearly see in Wireshark. Okay, and yeah, so you can see my computer 172.16.29.56 has given 8,442 packets, of which 2,058 packets have been replied by the scanme.nmap.org. Okay, so there are other communications as well, but this is the major communication that has happened by using IPv6 here. Okay, you can see this 45.33.32.156 is having so many ports that has been opened for communicating with my computer. Not only a single port, it has opened so many ports. Okay, it has opened so many ports in the range starting from 0 to 65535. So this IP has been given specifically by the Nmap website for understanding the scanning operations. Okay, so yeah. So this is how we'll be doing the starting the packet capture. We also have seen how the starting and stopping could be done by using this packets. So now we'll see how to save this packet. Till this point, I have not saved any of these packets. So in command line, I will show how to save the packets. So we have to use this particular command. Okay. So C#-I Wi-Fi is the command that is used for capturing packets. -w new.pcap. That means the captured packets will not be displayed now. Yeah, instead, they will be stored in a file called new.pcap. Okay. So you can see the number of packets are increasing in the bottom left of my screen. The packets are actually not being displayed. So the packets are not being displayed, right? You can see 4,000, 5,000 packets are actually going on, capturing on Wi-Fi, but it is not displayed. So I'm just stopping. Okay, I'm stopping the packet capture. Now I have captured 6,804 packets. Those packets are actually saved in a file called new.pcap. Okay, the same action in GUI. This is there. If I go to file, no, then I can save this packet as new.pcap. So I just save it in desktop. Okay, so I can save in many formats. You can see here pcap-ng format, pcap, and then Wireshark TCP dump packet, modified TCP dump packet, and Nokia TCP dump, Red Hat TCP dump, SUSE, InfoVista. So many packets you will be able to text format, all those formats you will be able to save the captured file. Okay, because it is huge, no? The compressed format itself would be actually available in Wireshark. Okay, so I just use the normal pcap file only. Okay, new.pcap, I'm just saving. Okay, now I'm just closing this file. And then I'm reopening the file which we have saved. In desktop, new.pcap is the file that has been used. And this is the file that has been opened after we have saved the file. Okay, after we have saved the file, we will be able to open the same file in command line. We will be able to open it by using yes. So with a filter, sorry, with a switch -R, you will be able to open the already saved file. -R new.pcap will open the file that has been saved in the previous capture with the name new. Okay, so you can see the 6,000 packets are now actually opened. Now we'll go to filters. Okay, so I just want to know one particular option. Okay, one particular option alone. I want to see what are all the packets that are having my computer as either destination or source. Okay, what are the packets that are having either my computer as a destination or host. Okay, so now only the packets that are having my computer as a destination will be, so my computer as a source or destination will be shown here. So my computer as source, you can see here from my computer, you can see here in this given packets, no, only from my computer, whatever might be the requests that are going to any other computer, that will be actually shown here. In the from address, no, okay, source address, only my computer is there. Okay, you can see. Okay, and destination address. So now all the packets with my destination address. From source address might be anything else, but my computer would be a destination address. Okay, the arrow says it's a destination address. Yeah, so this is how you will be able to use the filters. You can select the protocol, you can select the IPs, you can select the port numbers, you can do any kind of filtering with respect to this starting and stopping the, with respect to the Wireshark. Okay, so these are the GUI and CUI options of Wireshark packet capture. Okay, so we have seen the interfaces. We have seen how to start and stop the packet capture, display various fields, do the basic analysis on one packet, save and download the packet capture, reopen the same for analysis. All those things we have seen both in command line as well as in GUI. Okay, so yeah, source IP filters and destination IP filters can be applied both in packet header as well as other fields, and exporting the packet header attributes as CSV file or XML file we have already seen. And then IO graph analysis we'll see in tomorrow's class. Throughput, round trip time, conversations we have just seen. Throughput and round trip time we'll see in the tomorrow's session. IPv4 statistics also we'll see. Yeah, and this is the research perspectives of Wireshark actually. Okay. Analysis of protocols used in an academic network or my laboratory. Analysis of port numbers for abnormality detection. Analysis of SNMP and MIB variables. Behavioral analysis of IP addresses. Analysis of served and dropped packets in my network. All these things I can completely do with Wireshark. Okay, and these are some of the publications that has been taken. Okay, these are some of the publications that has been taken from Wireshark. Network delay and packet loss measurements for determining abnormal protocol usage for misuse detection in virtual environment. This is a publication that has done only with Wireshark. Let me show those publications. Couple of publications, let me show. Advanced baseline model and performance monitoring, real-time analysis. And this is the publication. Couple of publications I will show so that, yeah, so the advanced baseline model and monitoring for virtual environment by using Wireshark. You can see here, so you can see in the abstract itself, it would be actually mentioned. Okay, it is completely using Wireshark. So how the baseline setup could be done in the network. Okay, so what is the best practices and security baseline setup procedure. Okay, and what is the proposed architecture? So how do we set up the baseline? Okay, and what are the modules that are available, capturing the traffic, and how the traffic generation is actually done, and the code that has been used for doing the traffic generation. And yeah, so how the low traffic and medium traffic, see actually low traffic, you can see the time is simply measured till 1200 seconds, and then heavy traffic, no, you will be having the log scale that is actually mentioned, and then IO graphic for normal traffic is also actually shown. So likewise, you know, you will be able to perform any type of analysis by using Wireshark.
Hello. Hello.
Yes.
Hello.
Hello. Hello. Yes, ma'am.
Yeah, this is Shashikala, Madam, a research coordinator. Can you
Yes.
share this paper in the group, ma'am? Later for participants, it will be useful for us.
Yes,
Hello.
ma'am. Yes, ma'am. No issues. I will share it, ma'am.
Yeah.
Yeah. Thank you. So these are some of the papers. Okay, evaluation of QS parameters and hacking
Hello.
attempts. Yes. Let me show some of the other work. No. Detecting anomalous bandwidth usage by measuring the bit rate of video streaming traffic by using virtual environments. So yeah, you can see capture, analyze, and show statistics. How the traffic capturing is done, and how the analysis is actually done by using the Wireshark. And this is actually this has used the NTOP NG. So let me show this one. Network delay and packet loss measurements. That is perfectly possible in Wireshark. Okay, network delay and packet loss measurements for determining abnormal protocol usage for misuse detection in virtual environment. Okay, you can see here. Okay, so how the
It is published in book chapter, madam.
yes,
It is published
yes,
as a book chapter.
yes.
It seems that, yes.
Okay, so IO with the traffic analysis. Okay, so input output without generated traffic, it is actually shown. And then for each and every protocol, no, see, actually we will use some of the packet generation tools. Now, actually, I have generated traffic to a particular network by using TCP, right? So in the same way, we will generate various kinds of traffic and then analyze them by using Wireshark for low, medium, and high traffic. And these are the publications that are arised out of that activity. Okay, ICMP, packet graph analysis, and ARP, okay, DHCP, HTTP, okay, so DNS and TCP. Okay, so for all these packets, no, for a particular network, okay, for a particular private cloud network, so how the traffic is actually going without any loss. Okay, is there any packet loss? If it is there, for which protocol the packet loss is actually more, and what are the inferences related to the packet loss? Okay, those things will be actually clearly shown. Okay, so yeah, let me share these work, and also I will share one site wherein the publications of mine would be there, which might be helpful for you to go through and understand. So actually, I'm done with. I think I have run through the presentation because we are running short of time. And yeah, if you are having any query, no, you may just ask. Features, recognitions, promiscuous mode, and throughput RTT and conversation analysis I reserved for tomorrow's session. Research perspectives and publications, we have given some gist. And if you're having any queries, you may just ask it now. Sorry if I'm very fast.
Thank you, madam. Thank you for the wonderful session on Wireshark. So we got good knowledge how to use this. Actually, it's a free tool, so we downloaded it long back, but we don't know how to use it. So now we got good knowledge on this. Thanks a lot, madam. And we will be seeing you in other next sessions as well, tomorrow's sessions as well. Thank you, madam.
Thank you so much, ma'am.
Madam,
yes, sir, please.
I would like to thank you, madam. So, apart from your talk, you have given some sort of research input. So some of them who are interested to do some research with respect to Wireshark, how can go for publications. So in this aspect, you given very good exposures. Thank you, madam.
Thank you so much, sir.
Yeah.
Are there, if no doubts are there from the participants, we can just close the session. Thank you, Subbulakshmi madam, for the valuable information you have imparted.
Thank you so much, ma'am.
Thank you. And,
Madam, session is over.
yes, sir. Yes, sir.
So tomorrow only we can have the session.
Yes, sir. So we will be sharing the details in that group, sir, WhatsApp group, registered
Okay.
participants group, and also the group.
Hello,
It is given in the description of the group, sir.
hello,
Hello.
Okay, madam.
madam.
Yes.
Hello, ma'am. Please can you share today's PPTs and recording because some network issues we had, and in the middle it was interrupted.
Yes, sir. Definitely. We are recording and
It is a request, ma'am.
you
Please.
recorded videos as well as this.
Yes. Yeah, sure, ma'am. Thank you, ma'am.
And
Madam, is there any feedback?
sir,
Feedback link?
sir, you can share the feedback, sir, please.
Where, madam? The WhatsApp group or you can the mail you can share.
Share the feedback link as well.
Where, madam? Link is not there.
Sir, we will share end of day, sir.
Sorry, madam.
We will share it, sir. In the group, we will share.
Yeah. Okay. That's fine.
Right, sir. Yes, madam. We will be sharing the PPTs as well as the recorded videos. Thank you, madam.